becomes an amplifier. Beforehand, to give you an analogy, let me for a moment share a bird's eye view of how an amplifier works. Let me put this into an analogy like in a simple electrical circuit wherein now we know in an electrical circuit, if this is, for example, this is, just imagine this is your battery, okay? Then you have a switch so that you have a load, okay? Maybe a load okay, so let's say you have a battery, then put it in a circuit, then you put a load. Maybe this load is a coil, a solenoid, you know, a electromagnetic device, which when supplied with current causes a contact, okay, that this contact closes in order to produce, to become a switch, all right? So let's say this is an electromagnet, so that when it is operated by a magnet, this connects to a maybe generator, alternating current generator, so that hindi na generator. There is, let's say this is a 220 volts line, AC line, so 220 volts, and you have a motor, let's say this motor is 50 horsepower motor. So the motor is connected there, and the other is connected to the other. So before the 220 volts enters the motor, it has to pass to a switch. So this, you call this a contactor. This is, of course, this is an integral part of the contactor, and this is an electromagnet. Okay. So when the current is applied, the electromagnet operates. So the currents at the battery operates the coil, and then the coil closes the switch. Okay, so this contact closes so that the power from the 220 volts AC is closed in order to power the motor. Okay. Now if this is 50 horsepower and that is 220 volts, that that drains almost about ilang amperes? 50 horsepower, 50 horsepower times 746 watts per horsepower equals 50 times 746 horsepower divided by 220 volts. That goes to about the current that will be here. IAC is to the motor about 169 amperes. And the battery, if this is 12 volts, a control voltage of 12 volts or 48 volts, this only drains for a matter of, if this is 5 watts, that goes to only about 5 divided by 12, about 400 milliamperes. Okay, 400 milliamperes. Because the relay is only 5 watts. Now think about this, 400 milliamperes is able to switch the motor with a power of 50 horsepower. Di ba? Now, it's not actually the switch, the 12 volt switch that directly operates the motor, but it is through the relay or through the contactor. We call this contactor. Actually, a contactor is called a relay or a contactor. It is called contactor because of the electromechanically operated contact. Okay. The electromechanical contact is operated by an electromagnet. An electromagnet is operated by a small current, maybe coming from the battery. So in this case, if that is 12 volts and this relay is only 5 watts, the resulting current will be only 400, more or less 400 milliamperes. So that's about actually that is 0.416 ampere. So a small current of 0.416 ampere actuates on the electromagnet in order for it also to actuate another switch to close the motor. So in this case, you actually require a very small effort to move the 12 volt switch in order for the 50 horsepower to be operated by the contactor. Now, if we will relate this to the transistor, sabi baga natin ito ang transistor. Okay? This is the load. This is the battery. Okay. Positive. Okay, so this is negative. So we put a switch. So being this is negative, this is positive. The result, if we put a small negative current, sabi baga natin, what is required here in order to forward bias the base and emitter circuit. Okay, this is the base and emitter. We only need 0.7 volts. And the 0.7 volts as to how many amperes will appear between the base and the emitter will depend on the resistance between the base and the emitter. So in this case, if there is a, let's say, the input resistance at the base is 1,000 ohms, let's say 2,200 ohms, how much current will be present? That's a very small current, di ba? A very small current will trigger a a bigger current coming from another source, the battery. Let's say this is 12 volts. So the current going through the load will be much bigger than the current that is being present at the base. So if you relate this, if this load, if this load is like the motor now receives a bigger current coming from a separate source of 12 volts. And now, the input current of small value resolves to a bigger current value at the output. So in a similar way as in the electrical control, a small current at the switch at the input of the relay causes a bigger contact current between the 220 volts and the motor. So igwa ka ng idea kung paano. In this case, the amplification is because of the multiplication of effective current that is derived by the operation of the input current. Alright, so yan ang idea ng amplifier. Okay? So let's take a look at some of the sorry, nonce. Alright. So let's take a look at some of the uh, circuit. I get some web page from the internet, and let me share these web pages to you. Okay. So okay. So here is a symbol of a class A amplifier. By the way, the amplifiers, basic amplifiers are classified according to classes. There are three basic classes: class A, class B, class C, class H, class D. The basic class are class A, B, and C. Let us first understand what's class A. Now, the symbol often is a triangle that um, describes the input to be at the broaded base or the ones at the one side, and then the output at its apex opposite the side. So the input goes in here and the output goes out there here. Now in this case, look at the amplitude of the signal. The amplitude of the signal is low, but at the output it is high. In this case, it is inverting. The input is going up, but the output is going down. This is an inverting amplifier. Take note that it is 180 degrees out of phase. Okay, so let's see what's actually the diagram of class A. Now, this is the diagram of a class A amplifier. What is in the diagram? Now, basically at the base circuit, we have R sub 1 and R sub 2 as the biasing resistors. R1, R2 serves as the base bias. The R1, R2 determines the polarity or the instantaneous value of the current that is entering the base. So, at any instant, this R1, R2 is a voltage divider, wherein at the center of this voltage divider appears to be the input going into the base of the transistor. Take a look that the VCC or the source of the positive voltage is connected through R1 and then connects with R2 at the base and then goes to the ground. So the negative potential appears at the ground, and this negative and positive voltage is going to divide at the junction of R sub 1 and R sub 2 to determine the polarity of the base bias. Note that given the value of R sub 1, we can find R sub 1 and R sub 2, we can find how many volts will be present at the base with respect to B sub C, or how many volts will be present with respect to um, B sub G. This B sub G is the ground. Now, if the input current is going positive and this time the bias is positive, what happens is that the input current will add up. But there is a presence of capacitor C sub 1, and this C sub 1 will delay the input current that is going positive going current. Why is that going to delay? Because the capacitor needs first to charge, and the charging of the capacitor of the current, the charging subcurrent of the capacitor first has to increase the voltage, and the current will lag. Therefore, the charging of capacitor will be delayed. Pag-charge mo na siya, bago tumaas yung level ng voltage, pag tumaas yung level ng voltage, saka na siya magkakaroon ng influence. So kapag tumaas ang voltage muna dito at the delayed function, uh, it will influence the output. Now, since the output here is NPN, okay, take note this is positive. So if the input here is positive and it delays becomes negative, the input will first has to reverse bias, because if this becomes positive and here it becomes negative, it has first to reduce the negative or positive value divided by R sub 1 and R sub 2 in order to determine whether the base emitter circuit will be forward biased. Take note at the output that there is a zero value zero value of current at certain time after t equals to 0. Ayan, nagdumaan yung, ayan. So, this zero value tells that it first has to reach the at least 0.7 volts before the transistor is brought to conduction. Why is it that the input current here is positive and the output current is negative? Well, it is because of the inversion of the capacitor, it has to wait before it charges. And secondly, the inversion of the current, which turns out to be negative here. So at this instant, when the current becomes negative, what happens? Because the base is positive, there is going to be no conduction. Now, this no conduction current will cause to be a zero value at this in this at after some time at this point. And when the 0.7 volt is reached, that will start to conduct in the inverse direction. Why is that? Why is that? Because by the time the transistor starts to conduct, the transistor will appear to be a short circuit. And if this short circuit appears across between this terminal and across the R sub E, the ground will be seen at the output at that particular moment. Okay? So itong negative na ito will be swayed by the influence of the positive input signal na magiging negative muna. Kasi negative ito, kaya pa-negative muna. Mula sa zero value to maximum negative, bababa siya. Tapos pagbaba niya, pataas na din. Ayan. Pagdating ng zero cross, tataas na naman siya. Pag nagtaas na, meaning to say this becomes negative, so the transistor will start to be negative bias, meaning to say it's reverse bias. So when the transistor is reverse bias, it opens the circuit. So if the transistor opens the circuit, what will dominate will be the positive voltage present through R sub L. Yung positive voltage dito, yun ang magdo-dominate kasi nag-off ang transistor. Kaya makikita mo yung signal dito ay nag-positive na. Okay? So, naging inverse because of this. Okay? Now, as to why this is called Class A amplifier, it's because all the time, the transistors appear to be on the conduction state. Okay? The conductor is on the transistor is on the conducting state by the time that the signal input is zero. Okay? So, we expect that the transistor here is operating at a linear region, meaning to say the output is proportional to the characteristic of the input. Kaya kung sinusoidal ang papasok sa input, sinusoidal din ang lalabas sa output, except that it is inverted, meaning 180 degrees out of phase. Now, let's say class B. In this case, you see there are two transistor now, which is a pair of transistor in series with each other, so that the collector, the NPN is connected to the VCC, and then the emitter is connected to the collector, the emitter. So both emitter is connected. Wait a minute. May nagtatanong. Sana yun? Excuse mo muna. May naghapot na. combustion. Okay, now, madagos tayo. The class B and or class AB is called a push-pull. It appears here. This is a combination of two amplifiers actually, so that one is pulling up, the other is pulling down. Okay, while the transistor, the NPN transistor is pulling up the signal, the other signal is pulling down. Why? Why is that? The signal is common at both the input. So if the NPN at this moment is forward bias, that is going to push the signal up. Okay. In this time, if this as transistor signal, the PNP is reverse bias, there is going to be no signal. Okay, there will be no signal here because this is reverse bias. Diba? O kapag nag-positive ito negative, there will be no conduction. So this is not, by the positive value input signal, the transistor 2 will not conduct, but transistor 1 will conduct. Okay? So there is a positive value going on in NPN transistor going up. By the time the input signal zero crosses or meets the zero value at the horizon, at the zero cross, we call, by the way, we call this line zero crossing line because that the zero amplitude value, and then start to go down. That will be the time that the transistor 2, which is PNP, will conduct because the base is negative. So the base causes the input, the negative input of the base causes a negative current in the direction such that it will be in the same direction as of the, in the same displacement as of the input, but of the different amplitude. Okay, mas tumaas. Kaya ito tinawag na push pull, class AB push pull, because both the transistor works at the same time while complementing each other. When one works and the other is just waiting for the cycle in input cycle to reverse. Note that also that at 180 degrees of the cycle, they cut off. In this case, the broken line at the transistor 2 here suggests that this PNP transistor is not conducting, while in this it is conducting. So on the other next cycle, the second transistor is conducting. Now, why is it that this is called class AB? Okay, nasaan yung class B? Before we say it's a class AB, we must first, what is class B? Okay. In this case, okay. Why is this a class B or class AB? Okay, let us see. In here, the input is being filtered by the diode. Okay, so if that is being filtered by the diode, and the diode is in series, the D2 and D1 and D2 are in series, that means to say, at any moment, D1 and D2 are forward bias so that there is a continuous flow of current between the BCC through R, and then the D1, then D2, and then the R. Let's call this R in this R appears to be in this first resistor, and the other in the second resistor. Note also that the resistor here, okay, the I mean both the transistor are not the same. One is NPN and the other is PNP. So it appears to be just the same as this, except that the transistors, uh, except that the resistors are replaced by diode. So what is the effect of having replaced this with a diode? When that is replaced by the diode, what happens is in the positive signal, kapag nag-positive ang signal, magiging positive ang ano, ma, mag, mag, magre-reverse bias ang magiging positive itong anode, I mean cathode ng diode, the diode is going to be off conduction. Meaning D1 will be reverse bias. Therefore, the bias going into the base will be the positive value. Since this is NPN, okay, the positive signal will make the transistor to be in the forward bias direction. Therefore, it causes a forward current in the emitter and base circuit, causing the signal to be replicated in the positive direction. The same way here, so the same way, in the positive and the negative going signal, D2 will be reverse bias. So if this is reverse bias, because this is a PNP, the bias, the base will see the negative potential at this resistor. Therefore, this will be caused to short circuit or conduct. The transistor will be brought into conduction so that the negative value current here will appear. Here is this negative value. Okay, so this is now what is a class C amplifier? In the class C amplifier, the output is taken at the collector. Okay, take note. Take note here. The outputs at the class A are, although in this in the first diagram here, it is taken at the collector, but it is to the effect when the circuit conducts to its saturation, so that most of the signal will appear across the resistor, so that the output will become as if in the ground. Now here, in the class C, the output is taken at the collector. By the way, this is an RL circuit, capacitor inductor circuit. Probably this is a resonance filter. So that if there is an alteration here, the frequency will be filtered such that only the resonant frequency will be allowed to pass, so that the output voltage will be determined as to the condition of the conduction of the transistor. Okay. Now, a resonance is, it is a frequency at which the capacitive and inductive reactance are the same. So that when they are the same, it will appear that the resistance at the capacitance and the inductance is most minimum, pinakababa ng inductive reactance. Kapag nababa ng inductive reactance, meaning to say, most of the voltage at the BCC will appear yan, at the output, at the minimum resistance. If the increase in frequency here is seen, it will deviate from the resonance frequency, and the result will be the output will be either less in the negative direction or less in the positive direction. Okay? Bakit parehas less? Kasi kapag ang ang filter ay bumaba, bumaba ang resonance, lumayo sa resonance frequency ang input current, it's either the filter will act as if at the lower frequency and a higher resistance, or also in the higher frequency will also be in the higher resistance. So bababa ang output niya. Because it's, sabi ko nga, it's a resonance circuit. Okay, now here is the, for an AB, the characteristic of the uh, classes of the amplifier. Take note that the A, at class A amplifier, the amplitude is bigger given the same input. For class AB, it seems to be decreasing, but there is a, and B also. Now in the class C, because of the filtration of some frequency due to the RL's capacitive inductive circuit here, it appears that the conduction is not as continuous as in the class A. So you will notice here that class A is mostly being used in audio amplification, because it is here where the waveform can be reproduced as exactly as what is the input. In class AB, there will be time that there is no conduction in certain position, certain degree of the time, so that there is no faithful reproduction of the input signal. Just as in B, so much so in class C. So we can expect that audio equipment uses only class A for a better reproduction of sound, while for class AB or B or C, the amplification is only maybe for a transmission of coded signal, but not for a faithful transmission of audio signal, so that it can replicate what is being received at the input. Okay, let me share another. So now let's review the this is just the same circuit as before. Again, this is a class A amplifier. Take note that the R sub 1, R sub 2 just serves as a base bias to determine the forward reverse voltage between the base and the emitter, and the output still collected at the collector side of the transistor. And here is now the relationship of the ratio of the currents, where beta here is the um, beta gain. We call this the beta gain. Meaning to say, the beta is just the ratio of the input current times this quantity of the resistors R sub 1, R sub 2. Take note that R sub 1, R sub 2 are just are voltage divider. Ayan, oh. Now, the beta is the gain value, so that it determines how much gain will be available at the collector when the transistor is configured as an common emitter configuration. So yan ang kuan. The I sub CO is just indicates the collector current. Ano, how much current will be present here. And take note, if you sum up the value of the current, the I sub CO plus the I sub BO is equal to I sub EO. The collector current is equal to the base current plus the collector current. So it will appear here, of course. Finding it, it will appear in that ratio. Okay. Now, what is this? What is this figure? If the input signal is reflected to the point in the amplifier such that it indicates where the conduction is the input current reaches its conduction value. Okay, so at this point reflects the output at this point. Okay, now this input at the instant that it is considered there will be equivalent to the reflected output signal at this point. So that pag tumaas yan, ito na yung equivalent value. Pag bumaba, dito na yung value. Pag tumaas, ito na yung value. So the same way as in the previous page that we discussed. Again, this one is inverting the value. Ito pagbaba, ito ay pataas. Ito pa ay tumaas, ito ay bumaba. And here, the maximum efficiency will be equal to the output, maximum output over the average value of the output. This is another system wherein, okay, the input signal is in phase with the output signal. Kaya pagbaba ang input signal, pababa din. Actually here, what outs here is that because of the, not actually, because of the class B circuit, the base is reverse bias, so there is no input. There is no output here because it's the reverse direction. But when it starts to go in the positive direction, it starts to be in the negative direction. It's the opposite. Now here now is the push-pull, except that the output is inverted. Ito negative, lumabas ay positive. Nag-positive, lumabas ay negative. So this appears to be only complementary. Well, there is no point to confuse why this is going to be inverse or 180 degrees out of phase. Just remember that these transistors are not the same. This is PNP or NPN. This one is PNP. Positive, negative, positive. So yan. I want you to just look for this. Now this is a simplified diagram or representation of how the amplifier works. In this case, sabi natin, ito yung amplifier. Of course, the amplifier needs power. The input signal goes into the amplifier and it's the output signal that is represented at the at the side. In the diagram, this appears to be like this, while here the isobase appears to be a signal current, and the signal impedance appears to be at the side of the signal current. Here the signal voltage is present, and appears the C sub S is the signal impedance. If it is now combined, it appears that the input voltage causes line input to operate the impedance input, and then resulting to a gain of current. This gain in current will be due to the impedance output with an impedance current, output current, and then the voltage output of the output voltage. So here is the equation. V in out, well, it's just easily determined as to looking at the diagram. Okay, so the same. And here, you see that the decibel or the gain is appeared to be a weighted a gain is just equal to the 10 times logarithm of the gain a. So this appears to be in a decibel unit. dB means decibel. Look at this. We have the so-called bandwidth. A bandwidth is just defined as where the negative 3 dB appears before the peak value is reached. Kasi ang peak value nito may be somewhere here. Before, with reference to this maximum value, let's say this is a maximum value, kumbaga nag-clip na, dumiretso na yan. Yung negative 3 dB before the reaching maximum value, that's the lower gain at the lower band. Take note of the frequency here. The higher it goes to the far right, the frequency must be increasing. So at the lower frequency, there is also a gain such that that gain begins at negative 3 dB, and then it will rise. And then when it starts to fall at negative 3 dB again, that will be the limit at the upper bandwidth. That's why you have here frequencies of 1, frequency 2, meaning to say the response of the circuit varies according to the frequency. So that there is a certain frequency wherein the gain is negative 3 decibel. There is still another uh, negative gain at the higher frequency, which is negative 3 dB at the higher band, higher part of the band. So this is this is the expression of the sinusoidal Fourier series of the square signal. Well, we don't have to discuss this because we did not discuss yet the Fourier series. So here, okay. Now here is a interesting block diagram. You know, for example, of a TV system, the TV system just composed of several amplifiers. Each block of amplifier has its own purpose. It operates differently from the other, though it is complementary, meaning to say, it accepts the signal from one level and then amplify it with its own signal in order to produce another signal. So in this case, a TV block diagram is represented by the input of the signal which is picked up by your UHF antenna. Ito. Na, ngayon, yung USF antenna, makukuha mo din yung radio signal coming from the station in the range about 500 megahertz. That 500 megahertz is being combined with the local oscillator, combined in the mixer, in order to produce the intermediate frequency amplifier. Where is this intermediate frequency? This frequency is usually the modulating frequency of the TV. Although you cannot immediately extract the signal, but that carries the signal together with the sound. This amplifier is being controlled by the AFC, or so-called automatic frequency control. The automatic frequency control controls the oscillator, local oscillator, in order that the mixer will constantly multiply with the oscillator so that it will be able to filter out the intermediate frequency. And the intermediate frequency, it will be there that the vision can be demodulated. When it's demodulated, the carrier is taken in and maybe reproduced, maybe amplified, and then sent into the sound demodulation. Yeah, demodulation. Now, the process of demodulation is to decode the picture at the same time the audio. Okay. Now, in this case, from the vision demodulation, the intercarrier amplifier samples the sound. You know, in TV, there are two carriers. One, there are two modulations in TV. One is the modulation for the sound, and the other is the modulation for the picture. Separate silang tinatransmit, iba man yung sa sound, iba yan sa picture. Pero, at the same time, in the same real time, they are synchronized para yung salita doon sa screen, nagtutugma doon sa bibig ng nagsasalita. Nagtutugma doon sa voice. So here now, the sound is demodulated and then amplified, and it goes out of the loudspeaker. Na ang madugo talaga sa TV, yung tawag nito, yung picture, yung image processing, because after the visual demodulator, it goes into the amplification of its color. Kaya meron tayong luminance, brightness, yung kulay, red. And it is being put into the synchronized synchro syn, um, synchro generator, because the synchro generator will separate the signal that will be fed into the magnet. Okay, ito baga ang kasama yung magnet, ito yung magnetic yoke, to determine the horizontal and vertical convergence of the magnetic force coordinating the output beam. O kaya kung itong oscillator nito will just make the beam go left or right or up and down in order to direct where the electron gun has to aim the electron into the raster. And still, the line output will determine what will be the brightness, intensity, or which pixel is to be hit in order for it to produce the right color and the right image. Okay. Now, in this diagram is an FM radio diagram wherein the input is an RF amplifier. Ito yung signal mo galing sa air. that is from 100, from 80, because that is frequency modulated broadcast radio. The frequency ranges from 88 megahertz, I think 87.5 megahertz, up to 108 megahertz. That's the bandwidth for a broadcast FM radio. Now, the input signal, the signal that is picked up from the air, from the aerial antenna, is fed into the mixer. The mixer is mixed, receive also the local oscillator frequency in order to produce the intermediate frequency. This intermediate frequency now carries the uh, carries the carrier that carries the signal that where the frequency of the image is being uh, interfaced, and then the demodulator serves as to filter the frequency at the intermediate frequency, so that that can be compared and then become an output, so that this output voltage can determine the the range of the modulation and demodulation of the frequency. And after that will be the audio frequency power amplifier. Take note that there are two stages of audio frequency amplifier from the FM demodulator, and that audio frequency amplifier will determine now the corresponding um, characteristic of the audio signal that is taken from the demodulator. Sa demodulator, pinaghihiwalay dito ang carrier frequency at ang audio frequency. So yung audio frequency papasok dyan sa audio frequency amplifier, at yung carrier frequency ay babalik sa local oscillator para makorek kung anong value ng how many hertz, how many megahertz will be produced by the local oscillator in order to for the mixer to consume it and then get the receiving frequency be mixed again in order to extract the intermediate frequency. So ang lalabas diyan, ito na yung loudspeaker ay lalabas na yung pero I explained before the principle of the FM broadcast and the AM broadcast. Anyway, na-discuss natin ito, alisin natin. In this figure, you now have several transistors. There are 5 transistors present. The front end of the input composed of the Q1 and Q2. By the way, why is Q2? What is the purpose of the Q2 here? What do you think is the purpose of the Q2? If you take a look at the circuit, The Q2 has nothing to do with the signal input. Ayan. From the BCC through R sub 4, Q2 have a two resistor biases at R sub 7, R sub 8. Okay. Tingnan natin anong laman nito. Hindi na makita. Anyway. And the output signal is ordinarily taken at Q1. So the input signal through C1 gets into Q1 and then output goes to Q3. Now what is the purpose of Q2 if that is bypassed? Q2 serves just to stabilize the voltage at Q1. Okay, so wala siyang kinalaman except to stabilize the look at that. Q2 serves as a switch between the voltage divider R sub 4 and R sub 5. Okay? So if this Q2 is off, Q1 emitter will be dependent on what potential will be present at R sub 5. Meaning to say, Q1 can be negative if this is off. Okay? So if this is on, R sub 4 will carry the positive voltage to direct that voltage to Q sub 2 so that hello. Friends, naglilinog. Naglinog naman sa muya. Madali sa nang linog. The same characteristic as some months before, bigla sa nang minalinog. Okay, so Q2, by the way, I'm here in Naga City. And then, nagkubog-kubog naman si Daga. Q2, by the instant that the voltage supply at R sub 4 is positive, causes the Q2 to present a positive voltage at Q1 emitter. So R4 and R5 serves as a voltage divider when Q2 is conducting through the bias at the base at R sub 7 and R sub 8. Okay, R sub 8 must be coming from some other source in order to influence the bias at the base of the Q sub 2. Anyway, this Q sub 2 appears to be a stabilizer of the input signal. So the output of Q1 is being processed by Q3 and becomes the input of the Q4 and Q5. Q4 and Q5 are push-pull amplifiers, class AB amplifiers, which are determined, the output are determined by the biases at the base through D1 and D2 through R6. So, kaya ang output ng Q3 is taken at the emitter. So kung mag-conduct ito, magiging positive ito. Kung nag-positive, magre-reverse bias ito. And because this is PNP, this will conduct. So when this conducts, the output will be defined by the potential at B sub 2, BCC through Q4. By this time, if this conducts, this is not going to conduct because Q4 and Q5 are both push-pull amplifiers. Ito na ngayon. Well, class C. Wala nang content. Excuse muna, may example before. In the beginning of the lesson, we had an example of a topic of a fluorescent lamp. Okay. The fluorescent lamp simply just composes of a starter and the ballast and the fluorescent tube. Nowadays, actually not now, but since maybe 10, 20 years ago, the fluorescent lamp was replaced by a CFL, a compact fluorescent lamp. Instead of a induction ballast, it is composed with semiconductor oscillator. Okay, where is that circuit? Now, this is a circuit which connect to your fluorescent lamp. The input is 220 volts. Okay, there is a capacitor and then there is a resistor. The purpose of the capacitor is to filter the undesirable frequency at the 220 volts AC source. The R7 is a dropping resistor in order to work together with the C7. And then it is connected to a transformer. The transformer now is uh, produces the direct current. Take note of this transistor here. It's very interesting because the two legs of the high end of the winding of the primary and secondary are connected to the line voltage. Ayan, no? Uh, what is this? So this transformer one, since it has a capacitor in between at the serves as a filter. Okay, that filters out so that the sinusoidal voltage at the 220 volts will be purely sinusoidal as it enters into the diode. Now, the diode is a bridge type rectifier. Papasok dyan, mare-rectify so that the ongoing positive value will be outputted in the anode at D1, at D6 and D3, and the negative will be taken at D5 and D4. So the positive value, negative value output is filtered by C4, capacitor 4, so that here now is the supplied. This leg now is the uh, positive source of the direct current into the circuit, and here the negative side of the circuit. Okay. So what forms of this circuit? Take note of this. Two transistors Q1 and Q2 are configured such that they are in push-pull operation. Okay? So they are in a push-pull operation. What comes next? Anong mangyayari kahit nitong push-pull operation ito? Take note at only Q2, at the collector emitter of the Q2, there appears a capacitor C1 which is in series with this transformer 1, okay, T1 or coil 1 and inductor 1, and goes to the lamp. Okay? Now, through C1 from the lamp, there is an input going into the Q2 through D1 here, through R1 into the base. Ito, dito sa kabila, walang pulang pumasok. Yan. Purely, itong isang circuit na ito ng Q1 really just biases the base through D2 and R sub 6 and through the RC circuit, RLC circuit. Okay, this circuit. Ano nangyari? By the instant that this the output is DC, by the time the 220 volts AC is present, this converts into a DC, and this positive DC here initially charges C6. Okay? Pag nag-charge yung C6, magiging positive na ang terminal lamp 2, magcha-charge din ang C5. Okay? Pag nag-charge ang C5, mag magko-conduct ang L1, makukomplete ang circuit through C1. Alright, C1. Ano mangyari? Yung positive signal galing sa C6 through the terminal at lamp 2, nakaseries ng ay masisense ng input ng base Q2. Ito, Q2. Pag nag-positive yan, pagpa-positive ito, magko-conduct ang Q2. At the moment, before na pumasok ang signal dito ng through C6, yung positive value, it signals the tube to be positive so that the C6, C5 will become positive. And if that positive is seen by R sub 1 to Q2, Q2 will conduct. When Q2 conducts, what happens? Q2 conducts, this becomes positive, and this becomes positive, and this becomes positive. Okay, so C1 will become positive. Okay. And if C1 becomes positive, tendency of this is also to become positive. This will shut off. So the continuous presence of, by the way, by the time that this becomes, Q2 becomes conductive, magiging zero. Magkakonduct ito, magiging zero ang C1. And the time the zero value here, magiging negative ba yan? Actually not zero, but negative. Kasi negative ito. Magdi-discharge ang capacitor C5 and C6 through the lamps here. So what happens is there is going to be an oscillation. A Q1 and Q2 will be brought into an oscillation such that when Q1 conducts, Q2 will not conduct. By the time that this stops to conduct, Q2 will conduct. And the rate of conduction and then shut off or conduction, the cycle, will be determined by the charging and discharging of the capacitor C2 and C3. Okay? Kasi it is under the influence of the input bias at the Q2 and Q1 is being influenced by the RL circuit at the input of the base. Ayan o. Ano mangyari? Nagkakaroon ng oscillation. This oscillation, because this is a push-pull circuit, will determine the frequency present or the on and off of the conduction of the current into the lamp that causes the presence of high frequency conduction. Okay? So matataas ang frequency dyan. Anong mangyayari kapag mataas ang frequency? There will be a disturbance of molecules inside. Not actually molecule. There will be a high speed reversal of electron inside the tube. And that causes a in a vibration of the electron that bumps the phosphorus tube inside that emits the light. So basically, the CFL is composed of an oscillator circuit, so that the oscillator circuit will serve as the initiating medium in order for the electron to go back and forth between the terminal of the lamps. Okay, so this is a simple circuit that is present in your CFL. Ito baga o na picture out. Take note of this C5. C6 as the capacitor that determines the initial charge in the vacuum tube. Ito, vacuum tube, ano? And then C5. Sa pinag-aralan natin na introduction ng fluorescent tube, the C5 is a starter. In this case, the C5 is, instead of starter, it is made of a capacitor because capacitor can momentarily charge and then momentarily discharge. The continuous charging and discharging of capacitor, C5, C6, causes an oscillation here at the L1 inductor 1 and then transformer 1, and this is seen at the base of the Q2. So the Q2 will push-pull with Q1 so that the resulting value will be at a high frequency oscillation. Bakit mangyayaring pati itong Q2 mag-oscillate? Kasi kapag ito nag-conduct na Q2, ito baga NPN. If this is NPN, kapag nag-positive ito, kasi kung mag-positive ito dahil dito, pag ito nag-positive momentarily, this will short circuit. So this will conduct, this will come instantaneously negative, thereby discharging C1. Kasi pag nag-short circuit yan, mag-short yan, i-discharge yung C1. At itong C1, pag di-discharge mo ito close to dito, ito momentarily magiging negative ito. O sa magiging negative din yun, ang mangyari kapag negative yun, gano'n na, ito din mag-operate. So a presence of any polarity present in this junction, in the emitter and collector junction of the two transistors, will cause an oscillation on both through the signal present at the base. Okay? So, ganyan ang simple circuit na magagawa. Ano pa tayo ng ibang circuit? So, here is an example of an audio amplifier. Actually, this circuit is already the final end or the final output circuit of the audio amplifier. Take note, the speaker is an 8 ohm speaker. It is connected through the C3 or 100 microfarad capacitor. The speaker is driven at this point by two transistor Q3 and Q4, which is a post-pull class A amplifier. Okay, so that the trigger or the biasing of the Q3 and Q4 are driven by Q2, which is also Q2 is driven by Q1, where finally Q1 is the input signal of the um, at the input. So itong input, this can either be a microphone or a line input. It's already a voltage input received by the capacitor into the amplifier. Now R1 and R2 are the bias of the Q1 to maintain the stability of the potential present. And then the output goes to the Q2 through the collector of the Q1, and then Q2 will behave such that it will provide input to Q3 and Q4, which is a push-pull combination. So through R5, Q4 will determine whether it's going to conduct, and right away Q3 will be determined by Q2. Take note that Q2 and Q3 appears like to be a Darlington amplifier. Mag-research ko na lang kung ano ang ibig sabihin ng Darlington pair. A Darlington pair is a high current capacity amplifier. Two transistors connected in what we call it in tandem kasi magkasabay sila. One is a Darlington pair is basically two similar transistor, uh, dalawang PNP or two type of the same type transistor, so that when one conducts, the other two will conduct. Yan. So the signal here is made bigger by Q1 and it's made bigger further by Q2 so that it will be fed into Q3 and Q4 at the same time through R5 in order to produce finally the signal at take note that the signal at the speaker is actually being determined by the state of conduction of Q3 and Q4. It's expected here that when Q3 conducts, Q4 is non-conducting. So that positive value, the positive current will be present Q3 to feed it into the speaker. When Q3 stops, Q4 must start conducting to give a negative value through the speaker. Take note of the capacitor polarity. Okay. Actually, this capacitor is although it is polarized, but this capacitor must be a non-polar capacitor. Why? Because sometimes if this conducts, this will become negative. So the positive charge when Q3 conducts will turn out to be negative. Yan. But because of R6 as a feedback resistor, itong R6 is a feedback kapag ito nag-negative, magne-negative siya, so ano mangyari? Magdi-discharge ang capacitor. So that the positive value here can freely, the negative value here by mean, will freely make the capacitor discharge to negative, and then the negative will proceed to the speaker. Now here, the 9 volts battery is common. It's a one single supply to all transistor. Take note of this configuration. So that the biases on the transistor is only determined by means of the voltage division among the resistors. R6 here just serves as the bias. It is a feedback output obtained at the negative terminal of the capacitor or on the positive terminal of the speaker. Ayan, para ma-determine ano ang condition ng signal dyan, kinuha na ng sample. Pag tinignan mo actually, by the time that this becomes positive, so there is a positive value here. Mangyari, magpa-positive ito, magre-reverse bias ito. So this will be non-conducting. Kapag nag-negative ito, ano mangyari? Negative, pupunta doon. Pati mag-negative doon. So this is a, you can read, just read the, you can search for this, you can search for this. There are a lot, plenty of this in the, here is another example of the, by this time it uses the LM386. By the way, this LM386 is a, this is a kind of a integrated circuit. Pag sinabi integrated circuit, ang daming mga, it's already a component circuit composing of so many transistors. Now what is seen here, mga passive elements na lang ang nandito. Kumbaga yung mga external elements, na passive elements na lang para makaproduce ng filters, stabilizers, adjustment, gain control. Yan, volume control nandito. So yung input jack pumunta dito sa, one is in the ground and the other tip ring yan na. Actually a rheostat is a voltage divider to determine the position of the polarity. Kapag dinala mo doon dito, negative. So walang signal. So pag dinala mo positive, it is inverting. Positive and positive will increase the potential. This is going to be an now 386 is a very um, it is a common IC, commonly present. Makikita nyo yun ito sa mga audio devices ninyo, sa laptop audio, yung mga speakers. Kikita mo ito. Ito na yung circuit niya. Yan. So nowadays, we no longer resort to individual transistor circuit, but we only use the integrated circuit. Maybe our next topic will be integrated circuits, but um, maybe we can proceed not yet on the integrated circuit. I think we discussed some introduction on control circuits. A control circuit is still it can still be considered as an amplifier circuit. What is added into that is the interface of sensors and transducers, so that a control function can be obtained. Okay, so for now, friends, I think we'll just go over again next meeting. Maybe next meeting we'll discuss sensors, transducers, optoelectronics, yung mga infrared detectors,